guys, this is my first attempt at recording distance learning Precalc 2020-21. Let me do this real quick so you can see a little better picture of me. This is me without a mask, and my green screen is not looking too good right now, but sorry, my glasses have glare too. Anyway, this is going to be a struggle for me, guys, because I'm so used to teaching live when I can see, you know, you're doing this, ooh, what are you talking about, half-hour face? And then I can stop my lesson and reteach something. And so you're just going to have to do your best, take your notes, pause, rewind, and then email me if you still have questions. You can always look for other videos on Khan Academy and stuff too if I'm not doing a good job for you. I'm doing my best. All right, so this first lesson is just really a total overview of linear equations from Algebra 2. So we're going to go kind of quick here, and some coordinate geometry built in. Remember, you can always pause the video. All right, so the first coordinate geometry concept we're going to review is the distance formula. I always think of the distance formula, I'm not doing a very good job here, it's been a while since I used this tablet. I always think of the distance formula as just Pythagorean theorem, where the distance would be this diagonal here. So the difference in the x's is this length going horizontally. The difference in the y's is this distance going vertically. And if we kind of do Pythagorean theorem, we get the total distance. So this is the distance formula. If you need to write that down in that form, I always just think of it as the distance is the difference in x's squared plus the difference in y's squared. All right, so to practice that real quick, this would be an x and a y, and this one would be an x and a y for the different point. So I'm not going to use too much colors here because I'm going to go kind of quick. So if we were finding the difference in x's, and then the difference in y's, now you can type this on your calculator, and you can use, you will need the parentheses if you're going to do it on your calculator, okay? Because this is -12, and when we square it, it needs to come out a positive 144. Again, you could just type it all in your calculator. And this is 3 squared should be 9. And these are still under the square root, so we get the square root of 153. You should eventually be able to simplify radicals. I noticed that a 3 goes in here. If I divide that by 3, I get 51. Oh my goodness. Does this simplify? Because 3 goes into 51 again 17 times, just kidding. So 153 does divide by 9 to give us 17. Oh my goodness, that's a really ugly one. So this is the square root of 9 times 17. And if you remember reviewing simplifying radicals at some point, the square root of 9 is a perfect square, so he gets to get out of the little radical as a 3, and the square root of 17 stays in. That's about as ugly as they get. All right, so in the notes, I will go back and do this one. If you go back and look at the slides, it will have that one finished as an example, but for the video, I'm just going to do one. All right, that brings us to midpoint. Let's see, it looks like I need to move this up. And the midpoint, I always just think as you average the x's and then you average the y's. And this is a ordered pair when you're done because it's the middle of 2 points. When you average two test grades, you add them together and then you divide by 2. So that's what we're going to do. We're going to add the x's, divide by 2, add the y's, and divide by 2. You really need to memorize these formulas. Super important before you get to calc. All right, so for this example, again, we have x1, y1, x2, y2. Let me turn off that noise from my computer there. I think then you won't hear those little blings. All right, so if I add the two x's, if you were using your calculator, you'd have to hit those parentheses and then, or else hit enter before you divide by 2. Because remember, you have to add those before you divide by 2. So if I add, I get 2 divided by 2 is 1. If I add the y's back here, I get -3 plus -1 is -4 divided by 2 is -2. All right, so the ordered pair is 1, -2. You could, always graph that out and try to see if that was a reasonable answer, etc. But it's averaging the x's, averaging the y's. And it doesn't always come out nice. Could come out a decimal over 2. Or I'm sorry, a fraction over 2. Number 6, I will do as another example on the notes, but I'm going to move on the video. All right, next concept to review is slope. And slope, we have lots of definitions for slope. We always, back in the day, everybody likes the old rise over run, okay? The rise is up and down, so it is the change in y. So we use the definition change in y over the change, the run is across, so it is called change in x. And this little triangle is called a delta, and it means change in, and that means subtract. I don't know why my writing is so bad, but all right. So the fancy formula that you've seen before is down here at the bottom of the slide. This guy. All right, why do I just need to scroll, right? I'll get better at this, guys. Here we go. So this is change y2 minus y1 over x2 minus x1. And it doesn't matter which point you call which. So if you decide to call this point 1 and this point 2, doesn't matter as long as you use the same order for the x's and the y's. All right, so again, x, y, x, y. If I'm doing, the top has to be the change in y's. So I can do 13 minus 8 or 8 minus 13, okay? The way I wrote my arrow is 13 minus 8. Maybe I'll do both of these examples real quick. And then I would need to follow that same path with the x's for the denominator, and it is subtract, so it's -16 minus -4. So this would give me 5, and this would give me -12. Okay? I need to be checking my notes here so I'm not doing anything silly. All right, let me go through this one real fast using the formula, which says you take the second y, whoops, the second y minus the first, and then do the same thing with the x's, and that goes on the bottom. So here we would get 6 over 14, which would reduce to 3/7, okay? Just a little practice with slope. That's really important. And students, if you get it upside down, it's gonna be a struggle. You're gonna get the whole problem messed up from there on. All right, just a real quick review of some basic graphing. This one is nicely already in our favorite form, y equals mx plus b, or slope intercept. And that is the y-intercept. So this has nothing back here, so we put a 0, crosses at the origin. The slope is 4 over 1, and a slope of 4 over 1 means up 4 and 1 to the right, or you could think of it as two negatives. You could go down 4 and 1 to the left. Up 4, 1 to the right. Down 4, 1 to the left. Gives me a beautiful line. I'll cheat and use my line tool. There we go. And it should have arrows. All right. Moving on. Here's another slope-intercept line. So the only thing tricky about this one, all right, this b value tells us we start at 1. Remember, it's on the y-axis, not the x. But the slope of negative 1/3, either you go down and then right, okay, one of them is negative, not both. Or you could go up and left, but remember, only one of them has to be negative. So if I go down and right, or up and left, in the end, my very crooked line, okay, should be going downhill if it's a negative slope as I go left to right, okay? Now, there's a couple special lines. X equals 2 means if you were to do a little chart, all the x values would be 2, no matter what the y values were. Okay, that's how I always think of it. It does mean it will cross the x-axis at 2. So 2, 0, 2, 1, 2, negative 1. So this is a vertical line, which I drew really badly. And a vertical line that's crossing the x-axis at 2. Man, I can't even. All right, I give up. I'm making it worse and not better. I didn't stop it, did I? All right. If you were to do rise, it has rise but no run. So you'd get rise over 0, and 0 cannot be in the denominator. Division by 0 is undefined. So this one has no slope. We'll further discuss that in another question. All right, this is a special, this is in what's called standard form, and we're going to discuss that more in a minute. Oh my goodness, I'll get better at this writing on the tablet again, I promise. All right, so this equation is in standard form. You have two options. Most of you are looking at this probably thinking what we should do is solve for the y, so you could subtract x over to the other side and write 2y is, there's a negative x plus 6 over there, can't add those, not like terms, and then divide everything by 2 would be y equals, now there was a 1 here, so we have a negative 1/2 as the slope, and 6 divided by 2 is 3. I would like you in Precalc to be able to do standard form by finding the intercepts. That means you're going to put a 0 in for x, okay, and then it will just say 2y equals 6, which would mean y equals 3. So when you put a 0 in, you got out a 3. If you put the 0 in for y, all right, this would be 0, so it would just say x equals 6. So 6 came out for x when y was 0. Now you can plot those 2 points, and you didn't have to rearrange the equation. All right, so if I plot those 2 points, 6, 0, I always gotta say this out loud, means over 6 and up 0, or I'll put it in the wrong spot. And 0, 3 was the y-intercept over 0 and up 3. All right, let's check if that does the same as our line over here. If we started at 3 and then did a slope of down 1 over 2, down 1 over 2, down 1 over 2, we get the same line. So it is definitely okay to do either method. I just would like you to practice using the intercepts a little bit. All right, so this is a special form of a line. This one is a little less tricky for most students because you could imagine putting in the 0x. So it is crossing the y-axis down at negative 3. And it has 0 slope, which means no rise, only run. So it is a horizontal line, or if you put all the ordered pairs in, y would always be -3. So you'd go over 0, down 3, over 1, down 3, left 1, down 3. They're going to make a horizontal line, okay? So that's either way of explaining that. Again, it was horizontal, and that meant the slope is 0. All right. So we could try again with the intercepts for this one. If I put a 0 in for x, it would say -y equals -3, which would mean +1y equals +3. So I got 0, 3 as an intercept. If I put the 0 in for y, it will say x minus 0 equals -3, which just means x equals -3 when y equals 0. Sorry, I almost wrote that in the wrong spot. If you wanted to do the other method, this one you just got to be a little careful. You'd subtract x, and then you'd have to divide everything by a -1, or change all the signs, so you get y equals x plus 3. So 0, 3 here is up here. -3, 0 is over here. So I'm getting this line, which also works. If I had done this other method, it would have said the 3 here, and then the slope would have been 1 over 1, up 1 over 1, same line. Okay? And again, it's going uphill as you go left to right, so it has a positive slope. All right. That brings me to the next section of the video, which is on solving equations involving fractions. And you're going to use the least common denominator to divide things out. I put these section breaks in here, so if you need to review the video, hopefully you can look for this bright colored slide, and that'll tell you, oh yeah, I don't need that first section, I need to go second section, etc. All right. What you need to do on these, guys, I know some of you are going to go, wait, I can just combine these, they're like terms. Okay, what I want you to learn to do is to multiply through by the least common denominator to get rid of all the fractions. You're going to need to be able to do this when we talk about standard form and converting. And I want you to practice it with these because they make it so much easier. All right. 4, 8, 5, and 40. If I look at the biggest divisor here, 40 is divisible by all of these. So therefore 40 is the least common denominator. So I'm going to multiply everything by a 40. I'm going to be a good little math teacher and write it on both sides. Sometimes I forget and I just imply that it goes all the way across. All right, now I'm going to try my trick here. I'm going to put my calculator over here and make this screen a little smaller. And try to do this so that you can see what I'm typing on the calculator screen. Okay, so I'm going to do 4 times 9/4, or sorry, 40, and then I'm not even bothered with the times. I'm just going to put 9/4 in parentheses, or not because I can't type. This is why Hofbauer always uses the keypad on the computer. All right, and I get 90, and then I have to do 40 times 3/8. And I could put the negative in there if I wanted, or just write it as minus. And then I'm going to do 40 times 2/5. And finally, I have this one, but when you multiply by 40 here, the divisor should just cancel. So I should end up with, what did we end up with here? 90x minus 40 times this was 15, plus, if I'm doing it in my head, guys, 40 times 2 is 80 divided by 5, or 5 into 40 goes 8 times, and then times 2 is 16. You can multiply or divide either order. equals, and then here these divided out, and don't miss that negative that I almost scribbled over. Okay, make sure I don't erase that negative. All right, then we're down to a simple problem that we should be able to solve real quickly. 90x combine like terms. Subtract 1, use your calculator if you need to, but we get 90x equals negative 180. I should make this full screen again. Then if I divide both sides by 90, I get x equals negative 2, and that one came out nicely. Now, a lot of these won't come out nicely. I'm warning you ahead of time. All right, I'm going to go on to this next one. This one is super ugly. I'm going to skip this one for the video. I will show you on the slides, but I had to do it 3 times literally because I was trying to do it in my head and I made mistakes. So I'm going to skip to this one, and all I want to do here is talk about the first step. The common denominator here, this has a denominator of 1. So if we use 2 times 7 is 14, that will get rid of all the denominators. So I'm going to do 14 over here and 14 over here. Real easy thing to do is to lose your x's. Be real careful that you don't do that, okay? 14 times 3 divided by 2, or you can type on the calculator. Remember how I showed you on the last one. So it's really 14 divided by 2 is 7 times 3 is 21x. I'm using my shortcuts. Okay, and then it's 14 times 12 divided by 7, or I could do 14 divided by 7 is 2 times 12 is 24. And over here, 14 times negative x is just negative 14x. And then 14 times 47 is going to be something big divided by 7. But remember, I could cheat and go 7 into 14 is 2. And 2 times that is 94. All right, now I hope you remember you want to get all your x's on one side. And I think this one's going to come out nicely as well. So now we're going to do one that does involve distributing. And it's real important. You have to distribute first on these before you try to get rid of the fractions. It's real messy if you don't. So we have negative 11 over 4 plus, this is over 1, so it's 31 times 2, which is 62x over 8 times 1 is 8. Now that does reduce, okay? We can reduce it on the next step if you want. I just want your notes to show where it came from. And then when you do this step, you multiply the top and you get 62 again. And on the bottom, you do 8 times 3 is 24, which this will reduce as well. And then we have 7/4 x minus 82 over 3. Now, I am going to go ahead and reduce before we multiply through by our least common denominator. Because if we reduce this by 2, we get 31 over 4. We reduce this by, does it only, yes, it only just going to reduce by 2, so we get 31 over 12. Minus, and that's not divisible, I don't think, 82 over 3. All right, but if I look, my largest divisor of 12 is going to be divisible by 4 and 3, so I can use 12 as my least common denominator. So I'm going to multiply. Now I could combine terms on that left side, but why? Because I don't have a common denominator, it'd be messy. Let's just multiply through by the 12 on both sides. So here you can type 12 times negative 11 divided by 4. You should get let's see, negative 33. And then here, 12 times 31 divided by 4, I believe is going to be 93. And then way back here, 12 times 31 divided by 12 is just going to be 31. And over here, 12 times 7 divided by 4 would be 21. And here, I might need a calculator. 12 times 82 divided by 3. 328. Okay, I'm going to check that on my notes. Make sure I didn't do anything silly. Yep, I think we're good. All right. Whoa, what did I do? Need to slide this down a little bit. All right, on this side, if I combine these, I'm not doing the opposite, guys. They're on the same side of the equal sign here. So I'm just combining them. I get negative 64 plus 93x equals 21x minus 328. Make sure I haven't made any mistakes. I'm going to subtract 21x over here. And then I'm going to cheat with my work and add the 64 back the other way at the same time. You'll learn when we're in Precalc, we can start showing a little less work sometimes. Negative 328 plus 64, grabbing my calculator so I don't make a silly mistake. Negative 328 plus 64 is negative 264. And then if I pull out my calculator here, I have a negative 264 divided by 72. It comes out real ugly. You could write that down, but that's not an exact answer. It's going to ask for an improper fraction if you have this on your homework. So I would like you to practice doing the math enter, and write down negative 11/3. All right. All right, guys, this is actually the end of the first page of notes. And since the video is already 28 minutes long, I'm just going to go ahead and start a new video and call it part 2. Okay?